Hello, my name is Sam. This is my presentation of the Eclipse Monte Carlo code. So these are the amounts that or the shapes that I used essentially. So for the simple, I have two circles overlapping that have different diameters on the origin, and the complex one I have two different ellipses. So for issues with runtime and me having to edit the code down here in main, I did already run the complex one, accidentally ran it twice actually, but got an estimated overlap area of 20.2794. So I'll go ahead and run the simple one, and while that's running, briefly present my Eclipse class. So the Eclipse class contains this initiator, which is called down here. It takes two foci and then the axis length, which in this case will be 0, 0 for both of them, and then an axis length of 4 and 3. And then it has this contains function, which essentially just uses this distance to function to, using Pythagorean theorem, calculate the distance from each foci to the point that is randomly generated by the question I'll talk about next. Adds these two distance 2's together and sees that if it's less than the axis length, it will be contained within that eclipse. Show the main except reject loop of the algorithm. So that's down here. So a randomly generated number, which being between 0 and 1, I multiply that by the range of the x's and the y's plus the minimum. This will adding the minimums will ensure that it's actually within it, and then taking the range, multiplying it by this number 0 to 1 will give me good disbursement throughout that range, guaranteeing that all of them are inside the box. Turn that into a point. I use the contains on the first ellipse, and then the contains on the second ellipse. If both of them are true, then this gets accumulated. Coming down here, once it's ran through all 10,000 of them, take the accumulated or the accumulator divided by the total number of points, getting essentially a percentage that are within both of them, and then multiply that by the box area to get the percentage, or to get the amount of the area of the box that is an overlapping of both ellipses. And then in good time, the estimated overlap of these two circles is 10.9024. Thank you.